In this video, I introduce Reptile first-order gradient-based meta learning. Meta learning learns from small amounts of data so that the learned knowledge can be used to recognize the new tasks. For example, given a distribution of tasks, meta learning trains the language model that performs well when presented with previously unseen tasks sampled from this distribution. Reptile is a first-order gradient-based meta learning algorithm, which learns an initialization for the parameters of a neural network model, such that the model generalizes from a small number of examples at a test time. Reptile solves the following minimum problem as shown here to find an initial set of parameters phi for randomly sampled task tau with the loss error tau. As shown here, is a retrained language model. There's a meta learning that can quickly adapt to the new tasks. Where u tau k updates a phi for k times using data sampled from tau. In feature learning, u performs a gradient descent on batches of data sampled from tau. In model agnostic meta learning, for a given task tau, the inner loop optimization uses the training dataset, and the loss is computed on test dataset, which requires computing hashing of the loss function. Unlike MAML, Reptile doesn't require computing hashing and splitting the dataset, and instead, it only needs to compute the new model parameters phi tilde using stochastic gradient descent. The model parameters phi are updated by using this equation. The pseudocode is shown here. Reptile uses this as a gradient in adaptive optimization algorithm. For example, Reptile gradient is defined as here, where alpha is a step size. Reptile batch version updates the parameters phi on n tasks each iteration through average of the Reptile gradients, as shown here, where epsilon is a step size, phi I tilde is defined as u, and the updated parameters are on the task I. For more details, please check with these references. Thank you. Bye.